Hi, welcome to the third Glacier Image Velocimetry or GIV video tutorial. My name is Max van Veek de Vries and I'm going to be talking about accessing satellite imagery that's suitable for running through feature tracking in this video. Our objectives are going to be to discuss the main types of satellite image that you may want to consider using in GIV, discuss the formats that are accepted by GIV to make sure you download the right thing, and finally discuss some of your options for actually accessing the data. And I'll provide you some links if you're not sure where to get started there. So GIV runs with optical satellite images. There are a variety of different types of satellite image. The most common other kind would be radar images, such as Sentinel-1 or RadarSat. Those are not suitable currently for running through GIV. They need processing slightly differently. There are ways to run similar algorithms on this data, but that's not implemented in GIV. GIV runs with optical imagery or near infrared imagery. And the main data sources for that are Sentinel-2 and Landsat. Sentinel-2 provides an excellent high temporal resolution and pretty high spatial resolution too, from about late 2015 to present. Landsat goes back a lot further in time. The first Landsat images were in the early 70s. However, the spatial resolution is quite a bit lower. The Landsat 8, the most recent one, is 30-meter resolution rather than 10-meter resolution, with possibly a 15-meter resolution panchromatic band. If you're interested mostly in recent velocities, I would use Sentinel-2 data. If you're wanting to go back a bit further in time, if you need the past 20 years, for example, try looking at Landsat. Be aware that the Landsat satellite running from 1999 to present, Landsat 7, had an error called the scanline corrector error, in which it has a lot of dark bands in it in some areas, which can be an issue when using it for feature tracking. So you have to be careful with that. And then there are some other data sources that can be quite suitable, particularly commercial imagery, such as Planet, which you can also get for free as an academic up to a certain limit, usually as well. That's higher resolution and in both space and time usually than Sentinel-2, 3-meter spatial resolution, and often every day. However, the topographic distortions, the georeferencing of the data are generally less good. So you get higher noise in the resulting velocity maps if you don't spend a lot of time correcting for that. If you happen to have access to high resolution worldview, Pleiades, Spot, or any of those images, those are also definitely suitable for feature tracking. And the image formats that are suitable for running in GIV are either the basic image formats, PNG or JPG, which are ungeoreferenced. If you use those, you're going to have to manually enter the corner coordinates of your image in latitude and longitude, which will then be used to georeference the image. So be aware if you're using that, then you do need to find those coordinates. Otherwise, you can also run GIV using georeferenced grids, so running it with a geotiff. In that case, you don't need to enter the corner coordinates. They will be extracted automatically from the image. And you need to make sure you save the GeoTIFF in a format that has latitude and longitude. Generally, GeoTIFFs will be preferable. Running it with JPGs is particularly an issue sometimes because the resolution is slightly worse due to the nature of that image format. So if you can't access a GeoTIFF, try and save it as a PNG. If you can access a GeoTIFF, save it as a GeoTIFF. It's a lot more convenient. Finally, typically these satellites have a number of different bands. Like Sentinel has more than 10 different bands. Some of those are more suitable than others. I won't go into too much detail about it here. I usually use either just band 8 of Sentinel-2 or bands 2, 3, and 8. There's no limit to the number of bands you can have in your input image. However, be aware that they are all averaged to form a single band in the initial stages of GIV. So if you input a 10-band image, which in theory you can, it's not necessarily recommended, but those will all be averaged into a single band, but it won't cause an error when trying to run it through GIV. And finally, to just touch on where you can actually get this data, there's some pretty good public data catalogs for you to access this. Those are very convenient when you're just wanting to download a few images. They can become a little bit more tedious if you want to download a whole time series. You might have seen in the first video of this series, the Zero to Ice Flow video, I used EO Browser to download some Sentinel-2 images very rapidly. It's got a very nice user interface. For Landsat image, USGS's Earth Explorer website is a good data source as well. I will show you these in a moment, and I'll put the links in the description. You can also download images through a number of cloud computing resources. Particularly, we've started using Google Earth Engine a fair amount to do this. It's very convenient because you can crop, you can cloud mask, and you can do a number of fairly tedious pre-processing steps in the cloud without having to take up computational resources on your laptop. You do need to write some fairly simple JavaScript code to do that. But that is also a good option in a lot of cases. If you know how to use Google Earth Engine, I recommend that. And finally, there are custom download scripts. If you're wanting to run this sort of program on a very large scale, you can run scripts to automatically download Sentinel-2 or Landsat data from various data repositories. We're not going to go into this too much. If you're writing your own custom download script, you probably don't need me to tell you much about it, but be aware that that's a problem. Typically, one of the limitations of that when running velocities on a single glacier is that with custom download scripts, you download whole tiles, which can be a lot larger than individual glaciers and can take up a lot of memory space. So this is often a good option if you're, say, running this kind of code on a supercomputer or things like that. You don't need to worry about that now. Okay, I'm just going to show you very quickly some of those data options. So this is Sentinel EO Browser. That is a great way to access all the different Sentinel data sets, Sentinel-1 as well as Sentinel-2, Sentinel-3. You can get Landsat from here, but only the more recent Landsat. So if you're wanting to access, say, Landsat 7, I would recommend Earth Explorer that I'll show you in a moment. And it's very simple. You just tick Sentinel-2 and then search. And no matter where you are in the world, you can find useful data. And you're going to want to create an account. It's free and very quick. because that will give you access to slightly more download options. So if I choose an image here, then I'll just show you quickly the download options. I'll put a link in the description. I got a full video on how to download the details of some of this as well. But you can go into analytical, and here you can choose to save it as a GeoTIFF as well as a JPG or a PNG. I generally recommend a 16-bit GeoTIFF, or even a 32-bit GeoTIFF, and set it to WGS84 if you're running it through GIV. And there are a number of other things that you can do here. You can also like add your own custom script to pre-process the bands, which is quite convenient too. If you're wanting to access Landsat data, then USGS's Earth Explorer is a great resource. It also has a number of other older imagery. It has some of the corona imagery and all that in here as well. But basically, you can access all of Landsat 8, Landsat 7, and Landsat 1 to 5 in this portal. You just need to input your dates here and then search for data sets. And you can download all of Landsat data through this. And be aware that it will generally download full tiles as well. So if you're only wanting to calculate the velocities of one small glacier, you may want to pre-process this by cropping it to a smaller area. And finally, the method that I would recommend checking out as well is downloading imagery through Google Earth Engine. This allows you to pre-crop, pre-process a lot of the imagery in fairly convenient ways. You do need to sign up for an account and all that and do a little bit of coding if you want to do this, but it's generally worth it. Okay, thanks for listening. In the next videos, we're gonna look briefly at what pre-processing you need to apply before running GIV, and then the basic inputs in GIV.